The alkali metals are soft metals that tarnish rapidly, even in dry air. They have lower melting points and lower densities than most other metals. They all react violently with water, and as a result are never found uncombined in nature. Lithium is the least dense of all the metals. It is sometimes used to make lightweight steel alloys for high-performance aircraft. Sodium is the sixth most abundant element on Earth. Its many uses range from table salt to batteries, and it is one of the main components in seawater that makes it undrinkable. Potassium is the seventh most abundant element on Earth. It goes into glass, soap, and explosives. Rubidium is used in photoelectric cells, vacuum tubes, and heart research. Cesium, a rare element, particularly reacts with other elements. Scientists use it to help calibrate atomic clocks. And francium is possibly the rarest element on Earth. It is very short-lived and occurs as a radioactive byproduct of uranium decay. There is less than 1 ounce of francium in the Earth's crust at any one time. Like most other metals, the alkali metals are silvery metallic solids. They are excellent conductors of electricity and heat. The alkali metals are very reactive, and they easily form compounds with other elements. These compounds are generally alkalis, which are capable of neutralizing acids. Because they are so reactive, the alkali metals are never found uncombined in nature. In their pure forms, the alkali metals must be stored under oil or kerosene to keep them from interacting with oxygen or water vapor in the air. The alkali metals are as soft as cold butter and much less dense than most other metals. Lithium, sodium, and potassium are even less dense than water, so they will actually float. Coming into contact with water, alkali metals interact to form oxides or hydroxides, hydrogen gas, and heat. When lithium is placed in cold water, it melts quickly and moves around the surface of the water, fizzing. And this reaction becomes increasingly violent as you go down the group of alkali metals. Cesium is so reactive that it explodes when exposed to water. Looking at the periodic table can help explain the reactivity of the alkali metals. On the periodic table, the elements are listed in order of their atomic number. The atomic number represents the number of protons in an element's nucleus. In its normal or ground state, this nucleus is also surrounded by an equal number of electrons. And as the atomic number increases, generally so does the size and mass of the atoms. As you read the table from top to bottom, each horizontal line is called a period. Each period represents the number of electron shells the element's atoms normally have. For example, there are 4 electron shells in an atom of potassium, so it lies in period 4. Meanwhile, an atom of cesium in period 6 has 6 electron shells. As you read the table from left to right, the vertical lines of elements are called groups. Elements in a group have the same number of electrons in their outermost electron shells. These outermost electrons are called valence electrons, and they dictate how elements interact. Elements in the same group generally interact with other elements in similar ways. None of the elements greater than atomic number 83 are completely stable. All of these elements, including francium, are radioactive. All alkali metals reside in group 1 because they each have only 1 electron in their outermost electron shell. Because atoms need 8 electrons in their valence shell to be stable, the single valence electron in the alkali metals makes them very unstable, and they easily lose this electron to other elements. Generally, as you move down through a group, the atoms' hold on their valence electrons becomes weaker. So as you move from lithium to francium, each element is more reactive than the one before it.